Hi, I'm Sue. I'm a structural engineer. I have been a structural engineer for more than 25 years. And throughout my time being a structural engineer, I get a lot of phone calls. And those phone calls are, what's wrong with my basement walls? Or what's wrong with the basement walls in this house that I want to buy? So that's what we're going to talk about today, but not before I introduce the person standing next to me. This is Connor. Connor is an intern working for me this summer. He's not yet a structural engineer, but he's on the path to becoming one as he's attending school.
Yep, I go to Illinois Tech in Chicago, and I'll be starting my third year in just about a month here.
So this video is to educate people on what conditions exist in basement walls that could present some problems that you view. So let's talk about the loads on a basement wall. When you construct a basement wall, it's below grade. But initially when it's constructed, there's no earth against it. So it would just be a wall with air on both sides. Well, contractors, once they build the wall, they tend to want to build the floor next. That's a good thing to do. But in order to build the floor, they like to have a safe and stable platform in order to construct the floor from. So they'll backfill against the wall and you'll end up with the soil on one side and no soil on the other. This can be slightly problematic because the soil wants to do something to the wall. And there's 3 types of soil loads. And what are those, Connor?
So we have an active load, which is a load in motion. We have a passive load, which is a load that acts against the existing wall. And then we have the at-rest load, which is what would happen once the load's in place. So that's how we get this diagram here.
So the active load actively is trying to push over a wall that lacks restraint at the top. This would be a very normal condition for a retaining wall, but not something you ultimately have on your basement wall. Once the wall is constructed and the floor platform is in place, the wall is considered restrained and the soil load becomes at rest. But during this time, when there is no restraint at the top of the wall, typically what a contractor is required to do in the code is build some sort of restraining system inside of the basement to keep the wall from tipping inward once the soil is placed against the back of the wall. Otherwise, your wall looks like this. And this is actually a very common thing to see in a home. You'll find that the wall is leaning inward, and if you take a plumb bob and you hang it from the top of the wall, you will see it's tight at the top and there's a gap at the bottom. And this is an indication that this movement likely occurred during construction. Something else happens during construction that might tend to push the wall a little bit more. What do you think would happen?
I think that when people add more weight on top here, it starts to force the dirt out, or the soil out, and it causes the wall to fall farther.
Right, it's called a surcharge. So a lot of times you'll have a compactor, a piece of equipment that comes along here and they're trying to compact the soil here. This thing's heavy, it vibrates, and it creates a surcharge load that then adds additional force on that wall in a horizontal fashion. Well, it's not good for the wall, and what you'll see is the wall starts to bow inward even more. A clear indicator that this could have occurred during construction is also at the corners of the wall. So assuming that the building is rectangular, once you get to the corner, it becomes much more rigid and stiff. And at that point, the wall at the top can't really lean in, but sometimes you'll see a vertical crack there as well. So that is the forces during construction. But let's talk about once we put the floor system in place. Once the floor is in place, it acts as a restraint against this load. So you can no longer have this rotational movement. Now the soil load is no longer active. What is the soil load at this point?
The soil load is now passive, I believe.
It is actually at rest because the wall is chilling. It's not going anywhere. So this is the passive soil pressure right here. So as we have this at rest soil pressure here, the wall tends to want to bow inward. This is something you'll frequently find with masonry walls. You'll find a horizontal crack occurring in the joint between the masonry block. This is my cute little miniature version of a block. So you'll see in a basement a horizontal crack occurring somewhere around mid-height, and the wall will be bowed in, maybe not in this shape, but maybe more in 2 segments. So that's what you might see for an unreinforced masonry wall. Now, in the building code, both the Uniform Dwelling Code as well as the IRC. The IRC is the residential building code used in 49 states. The UDC is used in Wisconsin only, which is where we are. And in this building code, there are charts and tables that indicate how tall a masonry wall, basement wall, can be constructed with and without reinforcing. And it gives you the size of the reinforcement as well as the spacing of it and the thickness of the masonry blocks that can be used, because masonry blocks are either 8, 10, or 12 inches. That's a nominal dimension. Nominal dimension means that's what we talk about, but the actual thickness of the block is 3/8 of an inch thick less. Connor and I spent some time creating a model out of Legos, because everyone loves Legos, to further illustrate how this works. Our first Lego model shows a wall that is unrestrained at the top, under what would simulate a soil load. This photo shows a wall that moved at the top once backfilled. This Lego model shows the load on a wall when it is restrained at the top, also simulating soil load. Here are a couple of photos illustrating a wall that has bowed inward under soil load conditions. Thank you for watching our video. We hope you learned something today, and we hope you return again to watch more of our educational videos. Have a great day!